All right, for this bell work, we're going to solve this equation, and we're going to do it using principles of equality. So again, that means we're going to, whatever we do to one side of the equation, we got to do the other side. First thing I'm going to do here is look to force that negative 5.2 to become 0 so that I can isolate my 15.4 x's. And to do that, I'm just going to add 5.2. And you can see I've already set up my principle of equality. That's a line through the equal sign with just this line right here. So what do we get out of this? Well, this means I can take this 15.4x and I am able to drop it so that it is all by itself. I mean, it does have the plus 0, we're just not going to show it. So there's the 0. Negative 5.2 plus 5.2 is 0, just as we wanted. And then we also have 10.8 plus 5.2, which is 16. It's possible your calculator may show 16.0, and you could work with 16.0. I'm just going to make it 16 so I don't confuse it with 160. Last thing I've got to do on this is to make the coefficient of x a 1x. So that will also be a principle of equality. So that's that 15.4. I do not want it to be 15.4 coefficient. I would like it to be a 1 coefficient. And I can do that by taking that 15.4 and dividing it by itself. But again, if I do it to one side, I need to do it to the other side. So in my calculator, I got 15.4. 16 divided by 15.4. Enter. And it gives me a pretty ugly decimal, 1.038961039. So it's rounded for us. This means that this decimal is probably longer than this. It could be a repeating decimal, but I really don't give a crap if it is or not. What I'm going to do is change this into a fraction with the math enter sequence on the calculator, and that tells me that x as a fraction would be 80/77. Okay, now next I'm going to take this 80/77. I put it in for the x value. I say 15.4 times 80/77 because it's more precise, minus 5.2, and when I push enter, I see 10.8. And now I know for sure that, well, either one of these would work. This one's rounded, so it's possible if you put this in as the x value, it is a lot of typing. But if you put it in as your x value, it's likely it may be off just a little bit, and that's because it's rounded. So it's not exact like a fraction is, and that's why I prefer to put the fraction in. So our objectives, I can write equations from various contexts, and also I can use principles of equality to create zeros and ones to solve equations. We just did this on the bell work. But now we're going to have to write equations from various contexts. This is word problems, all right? So take 30 seconds and copy these two down, then we'll get started on the lesson. So when you're writing equations, it's going to take on this basic form right here. All costs equals the total. Now, today we are dealing just with cost, so there's a lot of money type situations. You have to know the difference between what a cost would be. Usually there's only two different costs in the problems we're writing, but they'll usually declare some kind of total. Maybe that's all the money you have or something like that. All of those would be totals. So we're looking for this type of setup. But it says, yeah, the basic form will be based on the information that is given. Now, this information given, sometimes it's not always obvious when you first read the problem, which means that you may have to read and reread the problem several times, actually. In fact, as we're doing it today, it's possible we may need to even do that at the end of the problem. So just be aware. This is a lot of reading, and you may have to read and reread the same problem several times before you really understand what it is asking, how to use the values as well. Now it says the variable should represent the objective. It should tell you what the variable is. So in the past we've been using a lot of x's, but today they may say, well, use p or t or s or a or something like that as the variable. So if they tell us to do that, we're going to have to use those, because on the assignment, if you don't use those letters, the assignment's going to mark those incorrect, even though you may have the correct equation. And then finally, since we're doing this by hand today on the classwork, we'll make sure to label our answers. We should always label our answers for word problems. But do keep in mind that on the assignment, it usually does label those for you. Now, the last thing I'll say about these is when you are writing them, sometimes you may write it incorrectly you're going to solve the problem and type your answer into the box. It's the answer that you got, but because you have set it up incorrectly, the answer is incorrect. So we have to be careful with the way that we set these up. Usually it's just a misplacement of the variable. So we'll have to keep that in mind. So what is the solution? Yeah, we'll be checking these, all right? And I'm just gonna use the calculator to check them, just like we did on the bell work. I'm not gonna actually write that work out, but I just wanna make sure that it will make the equation that we have written a true statement. And if it doesn't, then, well, clearly I will have made a mistake somewhere in there, which is common. Usually if I make a mistake, it's just a simple addition or subtraction, something small. Maybe I forget to carry over. Maybe I copy it down wrong. Okay, or maybe I just type it into the calculator wrong when I check it. So you have to be careful. It's okay to make those mistakes, but you have to find out where you make them. And then, yeah, principles of equality, which hopefully we feel pretty used to by now. The addition and subtraction principles of equality. So principles of equality, again, whatever you do to one side of the equal sign, you must do to the other side, whether it's any one of these four operations. But we're going to be doing these with purpose. If we use addition or subtraction, we are going to force values to become zeros. And again, the reason why we're going to be making these become zeros is because if they are zeros, then we get to ignore them. Just like we saw in the bell work. And then if we use multiplication or division, this means we're going to be forcing values to become ones. And again, just like we saw on the bell work, it usually means that we're going to make the coefficient to 1. Okay, so if the coefficient is anything other than 1, we'll have to use either multiplication or division to force it to become a 1. So again, when we look at these, because we could do anything to both sides that we want to, but we want to use these principles of equality to force zeros and ones. So here's our first problem. Under your cell phone plan, you pay a flat cost of $44.50 per month and then $5 per gigabyte. You want to keep your bill at $61 per month. Write the equation that could be used to determine X, the number of gigabytes of data you can use while staying within this budget. So we just read through the problem, and for some of us that's difficult, but we need to be able to read through the problem. Just read through it once. Now we can go back, like I said, read and reread these. I'm going to go back and just see if I can find some information that will be useful for us. And I'll keep in mind that I'm looking to make the costs equal to the total. Okay, so what are some costs that we have? Well, reading through this, you have a flat cost right here. It's $44.50 per month. And yeah, that right there is a cost. Okay, so it just calls that some kind of flat cost, so I'll label it as a flat cost. So you have this flat cost, and in addition to that, we can see in this problem, you're also paying $5 per gigabyte. So that would be a cost, the gigabytes. And I may have spelt that incorrect, but I also don't care. And then of course, we have the total also, which was given. That would be our total bill. So looks like that's just $61 per month. That would be our total. Okay, so again, we do have the cost. We have the flat cost plus the gigabytes should equal the total. Do we have those values? Yeah, well, we got the flat cost, definitely. It's $44.50. They gave us the total directly as $61 per month. So all of my costs added together should be that 61 bucks. So I have this set up, but the gigabytes right here is where we find that students have a lot of confusion. And here's why. It's because it's $5 per gigabyte. That right there is a rate. And so we have to pay attention to the other part of the problem that says X is the number of gigabytes. So it's possible that's per 1 gigabyte, $5 per 1 gigabyte. It's possible you could use more than 1 gigabyte. So to figure out the total cost of all the gigabytes, you're going to take the $5 and multiply it by however many gigabytes there are. This would be the total cost of all of the gigabytes. So I'm just I'm just dropping this down because on the assignment, this would be one box that you got to fill in, okay? But I want to be able to leave that there clean. But the next part right here, I've just copied it down so that I can start working with it so that we can actually solve this. And X represents the number of gigabytes of data that can be used. So we go to our principles of equality. And the first thing I see here is that I would want to zero out the 44.50 by subtracting 44.50. It's just if I do it to one side, I need to make sure to do the other side. So that will, in fact, zero that out. I can now drop my 5x's there, which equals, so I'm going to the calculator, 61 minus 44.50, enter, I got 16.5. Now these word problems like this can be interpreted even at this point. This means that just after you've paid for the flat cost, if you have the 61 bucks, you still have $16.50 to spend on gigabytes of data. So let's figure that out. We'll drop the X or the equal sign. But what I would really like here is not 5x's, but 1x. Okay, this will tell us how many gigabytes can be used. But to do that, I've got to change that 5 coefficient to a 1 by dividing not just the left side by 5, but the right side by 5 as well. So I got 16.5 divided by 5 is 3.3. And yeah, we can specify that, right? We can say, well, that's gigabytes of data. If I was writing this by hand, I would have just written gigabytes. Now we can check. We can say, well, look, you get your 3.3 gigabytes of data. This should be correct, but I just go to my calculator, I type in 44.5 plus 5 times, not x, but 3.3 now. And when I push enter, I see the 61, and now I know for sure that I've done this correct. So again, on the assignment, you'll expect 2 parts to this. You're going to have the equation first, and then you're going to have the value of x, or whatever the variable is. Now, one last thing I'll mention here also is that you could write the equation. If you want to write the equation just in a different order, you could. You could have said 5x plus 4450 equals 61, and you should still get full credit. It's the same exact equation, it's just change the order that they're written. The other thing you have to keep in mind on here is that most of these equations are not really necessary. So most adults, when they encounter a problem like this, which there are many, it's not likely that they would actually write an equation to solve it, and that includes math teachers. So usually you would just solve this. You would probably think about this and solve it with some logic, and then you'd be done. But here they're going to ask for equations. So in this problem, you buy milk and potatoes at the store. You pay a total of $33.98. So it says you pay a total of $33.98. Then you pay $6.06 for the milk, and you buy 4 bags of potatoes that cost the same amount for each bag. So a few things right here. It starts by saying, hey, look, you got your total. The milk, that's something that's going to cost us. And then the potatoes also will be a cost as well. All right, so when we set this up with the costs equals the total, in fact, I'll probably write it over here. I know that my costs, I've got the milk, and then I have the potatoes. Okay, so if I were to add those two together, I would get the total, just the total bill. And those values were given, right? So the milk, it says here, $6.06. I'll come back to the potatoes, but it said the total also $33.98. Okay, so how about them potatoes? Well, we know we're going to get 4 bags of potatoes. We just don't know how much they cost. But it does say down here that B will represent the cost of each bag of potatoes. So I'll have to keep that in mind when writing this part of the expression. I know that I am going to purchase 4 bags of potatoes. I just don't know how much they cost. But I do know if I were to multiply the cost by the bags, then I would have the total cost of the potatoes. So Now when we add those two, the milk and the potatoes together, we get the total. So this right here is the equation which it asked for. Again, I'm going to copy it down here so that I know that I just can work with it and make it clean. Well, from this point, I'm going to use the principle of equality, just like we did on that last problem. I'll zero out the 6.06 by subtracting 6.06 from both sides. That will zero that out, and then I can take my 4x's and drop them, which is part of the plan. Again, we're doing this with purpose. And then on my calculator, I got 33.98 minus 6.06, enter, and I get 27.92. So again, this can be interpreted. We now can say from the total, $27.92 went to the 4 bags of potatoes, but we want to know how much 1 bag of potatoes costs. So we're going to use the principle of equality here again and change that coefficient of 4 into a 1 so that it will show as 1x. So how do we change a 4 to a 1? We know from the principles of equality slide, if we're going to make 1, we can use division right here. So I'm going to divide by 4. Anything divided by itself is 1. I'll take 27.92 divided by 4 as well. I put it in my calculator. I get 6.98. Now, if you get to this point and don't label it, just be careful. We do need labels while we're doing it by hand. If you need to check, just go back to the problem and see B represents how much each bag of potatoes costs. We're looking at a cost here, not the number of bags. So make sure you label it appropriately with the dollar sign. Now, will this make the equation true? Yeah, 6.06 plus 4 times 6.98. If you put that in the calculator, you get 33.98. So we know that would make the equation true. So again, we have the equation and we have the solution. So this one, a group of friends wants to go to the amusement park. They have $311.50 to spend on parking and admission. Tickets cost $32.75 per person, and parking is $16.75, including tax. Right? Solve an equation which can be used to determine P, the number of people who can go to the amusement park. Well, first off, it says that they have $311.50. That right there is a total. And then we have a cost, looks like per person there, $32.75. But again, that is per person. You could also say per ticket. So that right there is a cost. And then in addition to that, you have the cost of the parking, which is $16.75. But again, that is a cost. So when I write my equation, I know I've got all the costs equals the total. And what are some of the costs that I have? Well, I've got just the parking to start with. And then I have the cost for the tickets for every person that's going. And then, of course, they did give us a total in there, so that's good to know. So this means that if I were to take the parking cost and add it to the tickets cost, I would get the total. So again, this is how it's going to set up. Do we know these values? Yeah, sure we do. It says right there in red that we've underlined that the parking will cost $16.75. The tickets are going to cost, it's $32.75 for every person. We just don't know how many people are going. It does say that we should use P as the variable for number of people going. So it's $32.75 multiplied by the number of people that are going, and then this would be the total, which it gave us at $311.50. So this sets up, I'm adding the cost, which should equal the total, but again, this is my equation that I'm going to solve, which was the first part of this question. So again, I'm just going to copy it down so that I can keep one of them clean. And now that I have it, I'm ready to solve it. So principles of equality, let's zero out the 16.75 by subtracting 16.75. If I do it to one side, I need to do it to the other side as well. So that's going to zero that out. Now we can drop my 32.75p, which we have just done. And this would equal just going to go to my calculator. 311.50 minus 16.75. Enter. And again, this means in terms of number of people that can go or tickets we can purchase, $294.75. Well, we don't want this variable here. We don't want the coefficient to be 3275. We'd like to know exactly how many people can go. So we're going to divide the 3275 by 3275. It's just, if I do it to one side, I need to make sure that I do it to the other side as well. But again, this will force the coefficient of x to become a 1, and this will tell us how many tickets can be purchased with that amount of money. So 294.75 divided by 32.75, enter, and I get a value here of 9. So I would be okay saying 9 tickets, but it wants us to label this as nine people. Just like it said over here, number of people. So those are our two answers, right? We have the equation here at the top, and then we have the actual solution, which would be 9 people based on this situation. So this problem, again, we're just going to read through it. You need to get a computer fixed. You took it to the repair shop. The technician at the store worked on the computer for 5.25 hours and charged you $185 for parts. The total was $490.55. So we will write and solve an equation which can be used to determine x, cost of the labor per hour. So they are telling us here at the very end, please use x as your variable, and that will be the cost of the labor per hour. Now, the other value that's associated with the labor is the time they spent laboring on the computer. That's the 5.25 hours. That right there is the cost, which is going to be the labor. Okay, so we do have a cost in labor. We also have the cost of the parts. So again, we're going to have to pay for the parts, but it is a cost. So the cost of the parts, $185. In fact, I'll change that. That's a cost for the parts. And then the total, they said $490.55. Again, that is a total. It says a total, but I'm just emphasizing that we know that that is a total. So when we set up the equation, we know that the total, well, it's just a total. But the costs, we have the two costs. We have the parts, and we have the labor. So I'm going to look at labor, and then I will add the cost of the parts. Okay, so adding those two together will give me the total for the costs, and then of course the total was just by itself its own total. All right, well, how much was the labor? We don't know. All we know about it is that it's X. That's what we're trying to figure out in this problem. But what we do know is that X is the cost per every 1 hour, and that the technician worked for 5.25 hours. So the total for the labor will be 5.25 times the value of X. The parts were $185, and then the total, it says, was $490.55. So if I add the costs together, then I get the total, as we see there. So that would be the equation, which again is its own answer on the assignment. I'm going to drop this though, so that I can work with one of them. And now I can use principles of equality to solve, just like we did those other ones, and also the bell work. So I'm going to subtract 185 from both sides. You may have noticed that the way that I have this set up, I have the X term first and then the flat cost. It doesn't matter which way you set that up, so just know it doesn't matter. Well, what will this do? Well, this what we just did. What will it do? Well, it allows us to take the 5.25 and drop it, which is what we want. We want it to be by itself, and then the 185 minus 185, yeah, that's 0. So then this would equal, I gotta go to my calculator here, 490.55 minus 185, enter, and it shows me that just the cost for the labor was $305.55. But again, we don't know how much the cost is for every one of those hours. We just know that they worked for 5.25 hours. So next up, we're going to make this a 1x and not a 5.25x. So to do that, we divide the coefficient, 5.25, by itself. And if we do it on one side of the equation, we must do it on the other side as well. So of course, 5.25 divided by 5.25 is 1. That's what we wanted. We forced that to happen. Now I go to my calculator, 305.55 divided by 5.25, and I get 58.2. Now you need to be careful about your labels, because when I did this originally, I put gig. I think I put what did I put? I think you put hours. But again, you'll notice that it's not how many hours that the technician works. So you need to go back and just double check. Don't make the same mistake I did. It's X is the cost. So when you look at this, it's actually a dollar sign right there. So I'm going to show it as a full dollars and cents right here, $58.20. And if you really wanted to be thorough, you'd write per hour. But I probably would never require that if you're doing this by hand. All right, but this gives us the equation. This gives us the equation here at the top, and then we also have the solution at the bottom. Will it work? Well, 55.25 times 58.2 plus 185, yeah, that'll work. Now, just one last thing before we finish up here. We got the X. Again, if you misplace the X maybe with the 185, you could solve this correctly, but it's not the correct answer because the equation is incorrect. So you may have the skills to solve these, but you need to have now the skills to set these up. So that's why we have our first objective. We need to be able to write those equations from various contexts. And yeah, they usually take on this form. The costs equals the total. And then yeah, we also need to be able to still use principles of equality to solve those. If we can't do either one of these, or just one of them, then we may be in bad shape.